So next we're going to use Solidworks CAM to load or to do the toolpaths on this part. Now Solidworks CAM is based on CAMWorks, which is feature-based. And so if you've used other CAM software, this can be a little different. What you have to do with feature-based CAM is you have to create features which will have your depth and some cutting parameters associated with them, and then create your operation plan based on the features. You can create individual toolpaths, but generally you only do that for cleanup operations. Okay. So let's get started. I'm going to go to my add-ins, and we'll select SolidWorks CAM, and then select OK. And it's going to take it a minute to load. Once it does, it'll add, I've got a couple of tabs here, and I've got 3 more tabs here. So there's my machine, my stock manager, my coordinate system, which is not defined. There's my CAM manager, all the same stuff, and my tool crib. Okay. So we're gonna do a couple of things, and I'm gonna actually show setting this up because the setup for CAMWorks is really important. Once I've got the setup done, everything else takes care of itself. So the 2 tabs here, I've got tolerance-based machining or TBM. We're not going to do that. That's really useful if I'm using tolerancing in my dimensions. Tolerance-based machining will pick a machining strategy that matches the tolerances. Very powerful feature set. We're not doing that. It's going to be straight up SolidWorks CAM. So first thing I want to do is over here my CAM options. I'm going to turn on, for the feature selection, I want it to find faces and part perimeters. Okay, when it goes to find the objects. So we'll select OK. Next thing I want to set up my tool crib. Okay, so this is a tool crib. This is just generic tool crib. The bench mill that I'm working with does not have this many tool spots, and the tool crib is what CAMWorks uses to decide what operations it's going to do. So having the right tool crib is kind of important. To change parameters like this, we use the technology database. CAMWorks works off of technology databases, or works off the technology database, which has all of our operation types, our machine types, and so forth. You can go through and set parameters for the machines and so forth. I'm not going to do that. We're only going to limit ourselves to working with tool crib. I've got tool crib 1, which is empty. Tool crib 2, which I see in the list here, has all of these tools. And tool crib 3 has a couple of assemblies. Okay. I'm going to go over here to tool crib 1, and I'm going to create a new tool crib. I'm going to call this bench mill 6100, and we've got 4 stations for this crib. We'll select OK. Okay. Now I went through and did a plan on this. I know what tools I want to use, so I'm going to add them one at a time. I'm going to add a flat end mill for tool number 1, and what I want here is a 3/8. So I'm going to scroll down here until I find my 3/8. And why it's hiding from me. I don't know why it's hiding from me. Sort by diameter. Let's see if that works any better. And we are 375. Scroll over. There's the 4 flutes 3/8. Select that. That's going to be station number 1. Save that. And add another flat end mill. It would be 1/4 inch. Flute. select that. That's me station number 2. Save that. We'll add a ball mill, an 1/8 inch 4-flute ball mill. Select that. That's me station number 3. Save that. And you can see my tool crib. I have a flat end mill, ball end mill. And I do have a little bit of an issue here. This one is diameter offset of 1, length offset of 1, tool 2, station 2, but diameter length offsets are still number 1. Make sure that I've set those to diameter length offsets to 2. And the same thing for tool 3. Diameter offset should be 3. My length offset should be 3. All right, and one more tool. So we'll add a countersink. The countersinks are the chamfer tools. I'm going to pick my 1/4 inch and my tip diameter, end diameter right here, D3, is actually set to 0. We'll set that to 0.01. And I'll save that. And then select it. That's going to be station number 4. Diameter offset 4 and length offset 4. Okay. Diameter length offsets are really important for the code. Save that. And there's my tool crib. And we'll just double check that I have a 3/8, 1/4 inch, 1/8 inch ball, and 1/4 inch chamfer. Okay. And this is my bench mill tool crib. All right, so go ahead and close the technology database. Go over here to my machine. Double click on the machine actually, and for the tool crib we will select bench mill, which has my tools there. Okay. Now when I go over to tool crib, I see I have my 4 bench mill tools. Perfect. Okay. Now I need to extract my features, and I need to extract the features, do an operation plan, and do my additional operations. And I need to set my coordinate systems. So I'm going to start off by setting my stock. So CamWorks, or Solidworks CAM, starts off with a stock definition that matches a part. Okay. I'm going to offset this a little bit. It's really important to know which direction is which. So vertical, because of the way the genome is pointed here, vertical is actually Y. So I want to add another 20 thousandths in the Y direction. And vertically, that means I need to add 20 thousandths here in the Y direction. You see that adds some material vertically. Okay. For X, I'm going to click there to say that the value for X added is uniform. 0.02 is 20 thousandths in X. Do the same thing on Z. 0.02 on Z, and that's the Z axis, not the milling Z. It can be confusing. Just use the numbers here, or don't even worry about that. Just click on values here until it changes the one that you want. That's the one that you want. That's the one that you want. Nice, easy way of doing it. As Julia Child says, when you're by yourself in the kitchen, nobody can see what you're doing. Okay? So nobody has to know that you can't keep the axis straight. Perfectly fine. All right, so we've got our orientations there. That's good. Select OK. And what I want to do now, I still don't have a coordinate system defined, so I'm going to click on coordinate system, and I'm going to pick stock bounding box vertex, top center. Z is going the wrong way. This is important for machining. Z has to go up. So I'm going to click here in the Z field. I'm going to pick any vertical line right there. That works. Z is going in the right direction. Y is going along the short axis. X is going along the long axis. That's perfect. We'll select OK. Now my coordinate system is defined. What I want to do now is extract machinable features. So we'll extract machinable features. And it'll go through and it'll find things. So there's my facing feature. Okay. There's my perimeter. There's my irregular slot. Okay. Perfect. I just have a couple more things I want to do. I need the chain for the chamfer. Okay, and I need the engraving feature here. So let's go ahead and get those. Yeah, I need the chain for the chamfer and the engraving feature. So I'm going to right click here and select 2.5 axis feature. I'm going to pick a boss as the type, and I'm going to tell it to convert it to loop. And I'm going to pick this edge here and this edge here. Okay. Now, features have a depth as part of their definition. That's our end condition. So I'm going to click on end condition. And because it's going to be a chamfer operation, I don't really care what the end condition is. But this depth is going to be used elsewhere. So I'm just going to leave the depth. I'm going to leave the depth there. And when we go through and do the toolpath, we'll fix it up there. And so we'll say OK for that 2.5 axis feature, the two irregular bosses. And lastly, I want to do an engrave feature for the letters there. So I'm going to right click, 2.5 axis feature. The type is going to be an engrave feature. I'm going to pick that shape there. Actually, we'll pick that sketch. Okay. And it's not enough just to pick the lines here, we actually want to pick the whole sketch. So we'll pick the sketch. It says we've got a valid profile. For the end condition is going to be the depth from there. 0.39 is way too much. Say 0.01. And we'll click anywhere else in here just to see that our distance is what we expect it to be. That's perfect. So that's going to be 10 thousandths depth for the, and it's going to use an engraving strategy on that. You can change the strategy there. And as far as that goes for the irregular boss, we're going to set a strategy here. So what we're going to do here is an edge break. So that's going to be a contour. And that'll take edge break operations from the technology database. That's something you can do when you go through, and when you go through this, we'll change this one as well. Use an edge break strategy. You could go through the technology database and change strategies like that, so that once you select a, once you generate the operation plan, generating the operation plan will actually do all the heavy lifting of figuring everything out for you. So let's see how that goes. We'll go to our NC manager and we'll tell it to generate an operation plan now that we have all our features here. And CAMWorks will go through and figure out all of our operations here. Okay, now it did a couple of things that aren't really good. It did tool 5 and tool 6 here for some operations. These aren't really what we wanted to do, so let's go ahead and let's just delete these operations and empty them out of the recycle bin because we neglected to do something. Let's go here to our machine. We'll tell it to use tool crib tools only. So we're telling it to use just the tool crib tools, And what it did, it went ahead and added tool cribs, added tool crib tools. CAM works, if you don't tell it to just limit itself to the tool crib tools, it will add tools if it thinks it needs a different tool. I don't want it to do that. I want it to limit itself to just these 4. So turn on Use Tool Crib Tools Only, select OK, and now we'll generate our operation plan again. All right, so there's our operation plan. It's going to start off with a 1/4 inch flat, and then we've got our various milling here, and we may want to reorder some of this stuff. Let's generate tool paths and see what we got here. So here's our first milling operation. This is using a 1/4 inch to cut those corners. Maybe I don't need that. I'm using the 3/8 to cut the outside. Good with that. There's my inside with the 3/8. That's nice. Cutting that slot there. Using the 3/8 to cut those corners up a little bit. Using the 1/4 inch to clean up the inside. Using the 3/8 to cut around the outside there. Got our countersink, chamfering that edge. I'm going to look at that in a little more detail. 3/8 clean up that. Countersink chamfering that edge. Okay, so what it didn't do the engrave, and it looks like the chamfer needs to be fixed up a little bit. And some fix up here is inevitable. This tool path here, clean up this corner, I don't really need this at all. So let's just go ahead and delete that one. I really want to group these by tool size. Okay, so I definitely want to have this 3/8 operation up here with the other 3/8 operation, and this 1/4 inch operation after. Okay. All right, so let's look at what this one's doing. This is clean up the outside, that's fine. Clean up the inside, that's fine. This may not be necessary. Again, like clean off the corners out there. This may not be necessary there. This is, and this is, and this is definitely necessary to clean those up. So, not sure I need this. And then let's go ahead and edit this one. So let's edit that tool path. Okay, so this is doing a chamfer, and our length is 15 thousandths, which is not really what I want. My clearance is 25 thousandths. And what I really want is I want a length of 0.05 and a clearance of 0.05. And the chamfer is actually on the outer edge. Except remember I picked my top edge there. Okay, and we'll say OK. And that looks a little better. Yeah, that looks a little better. And this one needs to be fixed as well. So we'll edit that definition. 0.05, clearance of 0.05, and the feature edge is the outer edge. And if you can't remember which one is which, it'll show you in the picture. Select OK. So those both look pretty good. Okay, and let's empty that operation there. Okay, so that looks pretty good. Last thing I want to do is I want to do the engrave. You notice it did not automatically do the engrave. So that's a 2.5 axis milling operation. And what I'm going to do here is I'm going to do a contour. The tool is going to be my 1/8 inch ball. and the feature is going to be the engrave feature. Select OK. And I'm just going to turn the lead in off. I never want to lead in on an engrave. We'll select OK. Generate toolpaths. It'll generate any toolpaths I need. There's all my toolpaths generated. I'll right-click here and simulate the toolpath. Now for the simulate, I want to have the stock set as shaded display and the part set to no display. That'll give me a better image of what's going on. Go ahead and play that. There's my operations. Okay, so got something funky happening here. Clean up the outside and clean up the bottom. Did not happen the way I wanted them to, so I got some additional depth in some places. Chamfer looks good, but it looks like I got some additional cutting in on the tool one around here. So let's look at which one that was. This looked good. That looked okay. Let's edit this definition. Okay. So what happened here is this did the irregular boss, which was the this edge here, which was the top contour edge. I actually didn't need to do that. Neither one of these should have been milled. So let's get rid of this one and this one. And delete those. And let's simulate the remainder. Very good. Okay. Looks like we're not getting a facing operation now, because this chamfer is very large and it did not cut the top. Everything else looks good, but we're not cutting on the top there. So let's take a look at that. We do not have a facing operation. So on our 2.5 axis mill, let's see, the face feature. And the face feature you see is not being used. See how it's highlighted in blue? It means it's not being used. So I'm going to do face mill from the 3/8 flat. Do the face feature. Select OK. And we'll just let it use the default features. Select OK. Change the feed value back to the max. Facing should happen first, so let's bring that all the way up to the top there and generate a toolpath. We'll generate, there's our facing toolpath. Let's try this again. So right click, simulate toolpath, run that, and there we are. So we've got our engrave, we've got our chamfer, all of our toolpaths looking pretty good. Select OK there. Good time to save our file. Yep. I'm just going to empty those parts out of the recycle bin. So we want to save this as now that I've got the toolpath done here, let's go ahead and post-process this. So right-click, actually, post-process, and I'll pick this as an NC file, put it on the desktop, run through, and you can do this to actually look at the code before you start, and it'll actually end up with a tool library. It'll show you which tools you're using when. Okay, select OK. We go to the desktop, and there is our G-code. Okay, so let's go ahead and save the file, and that is it for SolidWorks CAM.